Good everyone and welcome to another problem solving session with Special Maths Academy. So we're looking at problem 5, which I think was one of the most interesting problems in the second round from the just concluded second round of the Nigerian Mathematics Olympiad. So let's dive straight into the question. So let ABCD be a cyclic quadrilateral with point E, an interior point such that AB is equal to AD equals to AE equals to BC. Okay, as you can see, I've indicated the equal line segments with red. So let DE meet the circumcircle of BEC again at F. Okay. Suppose a common tangent to the circumcircles of BEC and DEC touch the circles at F and G respectively. So as shown here, so we see that D is extended to meet this point here at F, and there's a common tangent to these two circles as DEC and BEC, and passes through point F and point G. Okay, so I want to show that GE is the external angle bisector of BEF. Okay, so one of the important things that we should take note of here is that this is not a straight line necessarily. So this is GE. It's not necessarily a straight line, so it's something like going to be something like this. So if you extend it, it's going to be something like this here. So it's not really a straight line, so we don't want to make that assumption. Okay, so let's just move on. So one of the first things we can do, you can just chase some angles based on the associated triangles we're given. So we can say let this angle here be A. So let the base angles of the associated triangle here be A. This angle here be A. Let this angle here be B, and this angle here be B. Okay. So what does this give us? This gives us that this angle here is 180 minus 2A by virtue of sum of angles in a triangle, and this angle here is 180 minus 2B. Okay. So the reason why I put AA and BB is because we're talking about the base angles of associated triangles. So triangle ADE and triangle ABE are isosceles. With AD equals to AE equals to AB. Okay. So now, one of the other things we can do here is we can see that this angle here. So this angle here is going to be very important. It's going to play a major role. So we can get this angle here because this is a straight line when we have A and B. So this angle here, we just have to subtract the angles we have from 180. It's going to be 180 minus A minus B. And similarly, this angle here, because by virtue of vertically opposite angles, this angle here is going to be also be 180 minus A minus B. Okay, so yeah. Okay, and what else can we get here? Okay, so another thing we can get here is this angle here is going to be equal to 180 minus A minus B. And why? Because we have a cyclic quadrilateral. So the chord BF subtends the same angle. So BF, so based on chord BF or arc BF, we have that angle BEF is equal to angle BCF, so which is equal to 180 minus A minus B. So we can say let FC meet let FC meet BE at H. And there's something very interesting about this point H. Yeah. So I'll just can pause the video now and guess what's going to be interesting. So let's just say this is where our point H is. Okay, so let's say this is where our point H is. So we have that we can get this angle here. So now what is this angle here going to be? We know that opposite angles of a cyclic quadrilateral. So you can guess what point H, what's special about point H while I talk about before I get to that point here. So the angle at C in this cyclic quadrilateral ABCD. So ABCD is a cyclic quadrilateral given from the question. So the angle at A is supplementary to the angle at C. So how that the angle at A is 180 minus A, 180 minus 2A rather, plus 180 minus 2B. Okay. So the angle at A is this, which is equal to 360 minus 2A minus 2B. So it means the angle at C is going to be equals to 180 minus 360 minus 2A minus 2B, which is going to be equal to 180 minus 360. So this will change to plus 2A plus 2B. Which is equal to 2A plus 2B minus 180. Okay, so this angle here is 2A plus 2B minus 180. So let me just erase this here. So opposite angle of a cyclic quadrilateral are supplementary. Okay, so it means we can get this angle here. So what is this angle here going to be? So we can quickly do sum of angles on a straight line. So we know this angle at C, and then we know this small bit here. So we just add it together. So we add these two angles. So we have 2A plus 2B minus 180, and then plus 180 minus A minus B. So this is equal to, so we have 180 will cancel 180, and then 2A minus A is A, and 2B minus B is B. So this angle here is going to be A plus B. So it means this angle here, just got this from sum of angles on a straight line. So this angle here is A plus B. And you can add all these angles here and see that they all sum up to angles on a straight line. Remember how we defined point H. So have that HCF, the points on a straight line. Okay. So now we have that this sorry, I made a mistake. Sorry about that. So we have that these angles here sum up to A plus B. So to get this small bit here, we have to subtract it from 180. So it means this angle here is going to be 180 minus the sum of these other angles here, which is 180 minus A minus B. Okay. So you see that this angle here is also equal to the shaded angle. So let's put it this way. So sorry about that. So let's erase this. So you see that we can add this 180 minus A minus B plus 2A plus 2B minus 180 plus 180 minus A minus B. And we get 180 degrees as for the sum of the angles here. So yeah, it's just something we should take note of. Okay. Okay. So we see that this angle here is equal to this angle. Okay. So let's say this point here is H prime. Now, the angle, so very important. So the angle D E H prime. So now let's put it here. Let BE meet the circumcircle of DEC again at H prime. So I have DEH prime, which is equal to 180 minus A minus B, is equal to DCH prime. Okay. And why is this? Because the same angles subtended by the same chords are equal. So we see that DH prime subtends an angle of 180 minus A minus B. Okay. But then we've already gotten that DH. So let's put it here. We've already gotten that angle DCH is equal to 180 minus A minus B. Okay. So what does that tell us about this? So it means the angle between so it means the angle HCH prime is equal to 0 degrees. So this angle here is 0 degrees. So in fact, it means that point H prime and point H are the same point. So very, very important. That's why I said there's something special about point H. So it means this line so it means this line, this point, and this point are collinear. So we'll just put it. So this point, and this point are collinear. Very, very important. Very important. Okay. So what else can we get? Yeah. So now that we have this, we would want to okay. So let me just quickly make my diagram better. So now that we have this, what we want to do, we want to use this tangent, which is in this problem, which we haven't used yet. And to do that, we can just, so don't be scared if I bring in, more variables. And the reason why I can bring in more variables and not be scared is because I've used the first set of variables I brought in A and B to get that this point H here, that's the intersection point of BE and this circle, which is H. This point C and this point F are collinear. Okay, so very important. So I'll just write that in red. So that was the first very important result we got. So that's H prime and H, same point. So it means HCF collinear. Probably if you get this in the exam, they'll probably give you, a reasonable amount of points. So let's bring in some new variables. That's what we can do. So if we call this angle here alpha and this angle here beta. Okay. Now, since this is a straight line, very important, we can use some of exterior angles. So we have that this angle here is alpha plus beta. So very important, this angle here is alpha plus beta. Okay. And now we have that this angle here, which is beta, angle between chord and tangent is equals to angles of in the alternate segment. Okay, so it means this angle here is going to be beta. So this angle here is going to be beta because this angle here is beta. And this angle here, which is alpha, is going to be equal to this angle here, which is alpha. So in other words, let me just write it down somewhere here so I can erase all this. So can always pause this video and take note of the information I've gotten so far. I don't want to scroll up and miss the diagram. Okay, So we say let angle CGF be equal to alpha and angle CFG be equals to beta. So this implies that angle CGF equals to angle GEC, so angle in alternate segments, GEC because of tangency, equals to alpha, so we have tangency. And for a similar reason, angle CFG equals to angle CEF. Equals to beta, so because of tangency. And so when we add these two angles here, we have that angle GEF is equal to alpha plus beta. Okay, so this angle here is alpha plus beta. So this green angle here is alpha plus beta. So I want to show that this other green angle here is also alpha plus beta. So this green angle I just shaded red. I'm just highlighting it with a little bit of red. Is alpha plus beta. Now recall that we have that this angle here is alpha plus beta. So angle HCG is equal to alpha plus beta. Okay. So now we can quickly get that angle HCG is equal to what? So the chord HG subtends the angle of the alpha plus beta. So which other point can we pick? So we can pick point E is equal to angle HEG. So the arc HG. Okay. We have HCG equals to alpha plus beta is also equal to angle HCG. So we got that this angle here is also equal to alpha plus beta. And since this angle here is also equal to alpha plus beta, what do we have? We have that we're done. We have that angle HEG is equal to angle GEF. And so we have that GE is the external angle bisector of BEF. Okay, so this was a pretty interesting problem. So one of the things you want to take note of is that this point BC maybe probably was a distraction by the examiner. It wasn't really necessary. So this BC being equal to this other this other line segment was not used in our solution. So that'll be all. So feel free to comment your ideas and don't forget to subscribe. I mean, if you haven't subscribed, I don't know what you're doing. And like this video and share this video. And stay tuned for more interesting math videos and math solutions. So goodbye, guys.